Okay, in this video we're going to differentiate between three things: atoms, isotopes, and ions. And these are really easy to get confused. It's very easy to mix up which one's which, so let's go through the particles that make these up. Okay, we've got protons, neutrons, and electrons. And we've already talked about some of the basics here, but we need to learn how to interpret off the periodic table. So let's start with a simple atom. Now, an atom basically is something that we consider to be electrically neutral. That means it's got just as many positives as it does negatives. You've got a couple of things to identify. Now, no matter how your periodic table looks, it always has the same information, just might be organized differently. You've got a small number that's a whole number that always goes in order from left to right across the periodic table. That is our atomic number. Okay. And we also have a big number that's usually a decimal. Okay, and it doesn't necessarily have to be like a nice looking decimal. Some of them are close to whole numbers and some of them are not. But this right here is our atomic mass. So here's how we interpret these, okay? This atomic number tells us how many protons are in the nucleus, and that will not change. That's what identifies an element, okay? So in this case, lithium has 3 protons in the nucleus. Those are our positive particles. That's what makes it lithium. If something has more than 3 or less than 3 protons in the nucleus, it is no longer lithium. That cannot change. Those are inside the nucleus. We can't just remove a proton or add a proton to something else. Okay, that proton is very difficult to get to, and there's a lot of energy holding it together inside the nucleus. So that's what that tells us. Now, if we know that atoms are neutral, then you have to have the same amount of protons as you do electrons. It has to be the same amount of positives as you have negatives. So if I have 3 protons, I'm also going to have 3 electrons. In every neutral atom, those will be identical. The last particle here is our neutrons. Okay, now neutrons, this kind of has some change to it depending on the form of the element we're talking about. So this is a decimal down here that tells us the mass, okay, and that's a combination of protons and neutrons. This tells us 6.941. What that really means is there's more than one form of lithium out there, and some forms of lithium are more common than others. And this is an average that kind of tells you, if you took a sample of lithium, on average, how much would those atoms weigh. What we're going to do is round this to the nearest whole number, okay? That is close to 7. That means that's the most common form of lithium. Not the only form, but it's the most common form, okay? And if that number is 7, what we're going to do is take 7 minus 3, and we find that missing amount of mass. 7 minus 3 equals 4, and that right there gives us our neutrons, okay? Atomic number, subtract the atomic number and the atomic mass. Okay, and that's for typical neutral atoms. Now, if we work our way down the list here, a lot of things are going to stay the same. So your approach is not really any different. It's just there's something that maybe you have to interpret with a new twist. So let's take a look at carbon-14. This is an isotope. And what you're going to find a lot of times is this is just written out in words. It'll say carbon, or have a capital C, and then a hyphen, and then a big 14. Okay? Now, what that is telling us is it's a rarer form of carbon. Okay? Now, most of the time we look up carbon on the periodic table. Your common form of carbon would weigh 12. Okay? It's got an atomic mass of 12. This is a heavier form of carbon that's a lot more rare, but it's out there. That weighs 14. Okay, so all we're going to do is take this on our isotope, our more rare form, and we're going to get rid of that. This becomes 14. So when you get a new mass, you just replace that on the periodic table with what was normally there. Now we're going to interpret it the same. We still have our atomic number. That's 6. 6 protons, 6 electrons. Okay, this isn't a charged particle, so it's still electrically neutral, just like an atom. The only thing is it's a little bit heavier. It's got 2 extra neutrons compared to what it normally would have in a typical sample. So right now we take 14 minus 6. That gives us 8. This is 8 neutrons. So the only thing that changes in an isotope is the number of neutrons. Everything else is the same as it would be with that other more common form of an element. Okay. Now the last one is ions, and ions either lose or gain electrons. Okay? Electrons are on the outer edge. You're going to learn in lessons here that we can easily manipulate electrons. You can add electrons to an atom, you can scrape them off and take them away. It's not that difficult to actually manipulate how many are there. But it doesn't change what it is. Okay, what made this lithium was the 3 protons in the nucleus. What made this carbon was the 6 protons in the nucleus. So this is iron. It's still iron, okay? And it does not change what its nucleus looks like. So it still has 26 protons in the nucleus. I'm going to put a little plus out there because it helps me keep track of what the overall effect is. Okay. Now let's take a look at neutrons. We're going to calculate those the same. Iron gives us a decimal, but it means our most common form of iron is about an atomic mass of 56. Okay, so I'm going to subtract these, like I usually do, 56 minus 36. Okay. I'm sorry, 56 minus 26. It'd be nice if you had a teacher that could do math. And that's going to give me 30. 30 what? That's 30 neutrons. Okay, so I've got those two. Those don't change. That's the same approach we used before. However, electrons are different. Now here's what you have to think about. Electrons are the only thing that can really change. We can't adjust the protons in a nucleus without some kind of nuclear reaction. But we can easily manipulate the electrons. This number right here, when you see a little superscript, it means it's written up above the number. It's usually quite a bit smaller in the font size. Okay, it's a little tiny +3 up there. That means there's 3 extra positives. 3 more positives than there are negatives. It doesn't mean we added 3 protons to the nucleus. That would make it something that's no longer iron. It just means I have 3 more positives total than I do negatives. Okay, so what that really translates to is there's 3 less electrons. It must have lost 3 electrons. So if I take my normal amount of 26 electrons and I get rid of 3, this would be 23 electrons. Now if you look at this as a math problem, 26 positives combined with 23 negatives gives me 3 extra positives that aren't canceled out, and that's what this little charge here is really representing. So it's kind of counterintuitive. A positive charge, and you may want to write this down, positive charge means losing electrons. Okay? A negative charge actually means gaining. Because if I gain electrons, I'm getting extra negative particles. So this one's a little backwards from what your normal intuition would be. Hey, positive means something's going up. Not necessarily. In this case, it actually means you are losing electrons. Okay, so there's the difference between atoms, isotopes, and ions. Things students generally kind of get confused. Sometimes they will see this hyphen and a 14 and they think that's a negative 14 charge. Let me save you the trouble. You will never see a charge that big. Okay? The kinds of positives and negatives we see on ions, I mean, if you see a +7, that's a big deal. Most of the time it's +1, +2, +3, -3, -2, -1. Okay, so this right here, you'll also notice that's not a superscript. It's not written up above and it's not in a smaller font. It's usually just part of like one statement. Okay, so that's a little bit tough to differentiate between. Occasionally, students will try to subtract these numbers without rounding to the nearest whole number, and then you have an answer that says, I have 3.941 neutrons. That doesn't really mean anything. We want to just round to the most common form of this element. Okay, and the last thing that's always messed up is the positives and the negatives are misinterpreted. So make sure you write this down. Positive charge losing, negative charge means it's gaining. And there's your basics on atoms, isotopes, and ions.